Welcome back, guys. We are in the second session of the technology radar for manufacturing. Just to recap from the last session, we briefly looked at the definition of technology radar and its components. We looked at the emerging technology radar. We looked at the manufacturing radar. In the current session, we are going to go a little bit deeper into each of the technology and understand as to which journey map or how the journey map going to be. So, the first one that I want to look at is the wait and watch. That means, these are new technologies that are emerging, and it has the potential to dramatically change or impact the industry. And there are certain early adapters of this technology. People, process, standards need to be evolved in that. So, where does it stand is what we are going to be looking at, right. So, let us go into the radar companion and see what it says. So, circular economy is about is a term describing the economic model that separates the ability to achieve economic growth from consumption of virgin natural resources, and this is based on closed loop system, and the idea is to reduce pollution and to the extent possible encouraging the returning, recycling, remanufacturing and reuse of product and materials. It becomes very important in the manufacturing aspect of it. So, let us look at some of the trends that we see in the market, right. It is, like you said, this is based on the closed loop system that reduce pollution and to extent of life cycles, products and materials by encouraging return, recycling, remanufacturing and reuse of products, right. Now, so in terms of the model that people are adapting, you can see the flow chart here. Normally the raw material comes in and the design is what is consuming the raw material and gets used in the manufacturing consumption. And when during the consumption life cycle, there is some maintenance you may be doing that, and then when it comes to the reuse and refurbish is another cycle that you will do. But before you discard, what we are trying to do is to figure out from the product which are the part that could be potentially reused is what we are looking at effectively. And then the recycled components feeds into the raw material part of it, and then it completes the cycle, and the residual waste is the one that is going, right. Now, if you want to look at the one that needs to look at the circular economy is probably the PCB industry or electronic industry. Electronic waste is a major problem for us, and how do we make use of the raw material and then have it sustainable is something that we need to look at it. Whereas, if you look at somebody like automobile manufacturing, they have adapted the circular economy in a much more effective fashion, and some manufacturing are able to say that they only have 2% residual waste in the in their cycle of operations, right. So if you look at the overall picture, the data suggests that the companies are engaging in a piecemeal convention resource and cost efficiency initiative, and they have not completely integrated all the activities together. So, that is the one that is giving the indication that you have to wait and watch in terms of standardizing so that everybody can look into that. But whereas, if you look at the manufacturer or retailer, they have embraced the circular economy and they will alter their business model, operating model, value proposition, product and service offering even is coming into a new model. There is a link that I have given here. I don't know if it will. So there is a link that you will be able to check out later on, that is talking about how Renault has completely achieved the circular economy in a much more effective fashion. Okay, so much for the circular economy. It should have given you an indication of the nature of weight technology. It still gives you transformational benefit. How do we look at evaluating then and build our journey map around that? Let's look at the next technology, right? We call it smart assets, right? You know, this you are probably familiar with that. So smart assets are records of assets stored in a blockchain and a distributed ledger, where the ownership and the transfer can be managed through smart contracts. And the smart contracts is improving. The programming environment is using a framework called Solidity that is also becoming very popular in the market. So the flow, the activity, the fulfillment, the SLAs, all these activity we depend on human beings to fulfill it, whereas in smart contracts all of them happens in a automatic fashion. Again, you know, we are saying wait and watch, not because of the technology that needs to mature, but in terms of practices that need to mature with respect to each of the operation. If you look at manufacturing as a whole, even within manufacturing, automobile is very different from let's say discrete manufacturing, right? So the flow that we have and the operations that we need to do, the quality control that we need to do, everything becomes different. So in order to manage that effectively, the smart contract will have to be configured differently. That's why that variation will happen between the industry, if you will, right? So what are the different components that are affecting, right, in the smart contract? And that's given in the picture on the left hand side here. So what you have is the predictive machine analytics managing the overall productivity of the machines here. It will be able to tell you about failures before it happens, so that your overall workflow is effectively managed. And the industrial augmented reality will help you to figure out about defect in a much more effective fashion. And the IoT and supply chain management will help you to improve the flow of your manufacturing. And there is this technology called cobots, means that they are bots, but they will be able to work with the human beings, variations or customization if you need. So they are looking at augmenting human beings' efficiencies and productivity. So they work as well in synchronization. And the modular equipment will help you to manage your workflow and the configurations of the cobots, and the computer vision will help you to do the quality check on that. And the IoT embedded system will track all the products that you are deploying into the customer environment, right? You know, and the unmanned tracks will make sure that the end user delivers it. So if you look at the overall flow needs to happen in a very effective fashion without much human intervention, and most of them is done by the a specific value that are there in the flow, and that is managed by the smart contracts, right? So all of this becomes very important, and in order to adapt the smart assets, how do you go about doing that? You know, that is what is given in the right hand side. We need to do a we need to have conduct an inventory of organizational transaction, workflow, business process, and figure out what are the participating entities in that. And then we need to consider the interaction that can be encoded in simple programming rules. It could be that your assets, the delivery needs to happen within specific time, maybe within some specific temperature. If you look at pharma, the output will have to be maintained at specific temperature even while getting shipped in the air or something like that. So all of them need to be captured within the smart contract programming. And then we have to identify the virtual assets that will play a key role for our business in the future, where the smart asset technology can play a role. So that becomes an important aspect as well. And then if you look at the blockchain per se, there are many platforms that are available in the market. Figure out which blockchain will be more suitable for you to implement. Most of the blockchain is an open source. You will be able to use any of them on that, right? So this is what is involved, and it is a very impactful technology, and you will be able to use it for your productivity and efficiency, but you need to develop skills around that to make it happen. So now let's look at some of the adapt one, right? So this one is a very very thought provocative, imaginative, creative aspect of it, right? So generative design is, the word itself is very provocative, right? The design need to be automatically generated. Can it be done? 5-10 years back it would have been difficult. Today it's very easy because there is this AI grown technology called generative application network, adversarial network, which is called GAN, right? And it's able to figure out as to from the past design that you have and the user orientation that is out there and the feedback from the customer, all of them put together, if you are able to design it, then you probably, we had been doing it manually, and the person who is able to do this is called some kind of a guru in design and things like that. But interestingly, using AI, you will be able to do that effectively. And this is already being done by many of the CAD tools, such as Augmenta, Autodesk, STCO, PTC. They are all looking at it. It's not only in the progressive manner, looking at all the past design. Can I improve the shape? Can I improve the material strength of it? Can it have more light if it is an architectural system that we have? Can it be more resilient? Can I make the design more environmentally compliant? Like we talked about the circular economy, right? Can I make the design in such a way that we have 100% circular economy based or recommended material? All of them becomes suddenly possible, right? So that's why the generative design becomes such an important one for manufacturing. That's why we are saying pilot, do a pilot on that, and it's going to have an impact on your manufacturing, and you will be able to come up with the best possible design. Not necessarily, they used to have another technology glyph called crowdsourcing. You look at all the global players, and then they will contribute to that. Using that, you will do the design. Not like that. This one is more like, the intelligence is gathered and it is put in the artificial intelligence framework, and it will be able to come up with a recommendation, and then it can tell you about some of the trends, some of the constraints that you have. Within that, you will be able to design your solutions, right? So the generative design algorithms can be multidisciplinary. That means, it can have design aspect of it, it can have strength of material aspect of it, it can have environmental aspect of it, policy design aspect of it. It can be multiple things, incorporating aesthetics, cost, sustainability, function, reliability, manufacturability, serviceability, all of them can be converged, and it can really handle the complex wicked problem as well. So, I have given a link that has looked at the various technologies and architectural solutions that are out there. When you have some time, take a look at that. Let's look at the next technology here. Right? If there is one technology that has been beaten to death in the last 2-3 years, it's machine learning. Right? Machine learning is going to have impact on every other technology that you have, every other industry that you have. Right? But let's look at some of the aspects and vectors around it. Machine learning is a technical discipline that identifies patterns and generate prediction based on analyzing large set of data. Right. So, there are major 3 subdisciplines that we have to be looking at it, supervising learning, unsupervised learning, and then reinforcement learning. So, these are the components that you need to be looking at it in terms of practicing it, right. So, you need to adapt machine learning from this aspect, that is, do you have a competitive value built around the solution that you are doing. That is very high, right. If you are saying that I have put machine learning to use in order to derive a particular solution or service, and that will give you a competitive edge for you, right. And almost I would say all the vendors are looking at machine learning as an aspect. It is also based on data, it is based on audio signals, visual signals, and it's also added with the generative adversarial network. There are several components that are coming together in that. So I think piloting the machine learning becomes a very important technology that you need to pilot right now. It's more like right now we got to adapt that, that kind of a technology is what we are looking at. So, adapt is very interesting, right. That means that people, process, technology, standardization, everything is matured there. You just have to look technology, adapt technology and start using it, and that's what is adapt is about. Here we looked at the immersive experience, AR, VR and MR, right. So there are some solutions that are there in the market that are completely fascinating, right. Software went through something called DevOps, development and operations combined together, and they felt it can be done by one person or one resource, right. Here what is happening is sales and service, can you merge together? And the answer seems to be, yeah. What do we need? And let's say you want to service a part. That means you need to know what are the components of the machinery. You need to know how to open it. You need to figure out which component is going where. You need to disassemble it, do some service on it, and do it. And all of them, very interestingly, can be done using the AR. You look at something like a machine part, what you see on the right hand side, and your tablet or your mobile. If you can develop app, or there are some already existing app, you show that in the camera, it will show the internal parts of the engines to you, and it will tell you sequence by which you can open it up, dislodge it, and you will be able to service it and put it. So interestingly, how do we used to do this 5-10 years back, or even year back, or even in some places now? You go through some reams of manuals and figure out which component is there, go through the standardized coding, you need to know the standards. There are a lot of paper related, reference manual related complication is all taken away, and your productivity is increased like anything in this. And this is about one aspect of the AR. The application in terms of where it can be applied, how it can be used is, typically they use only technology, technology and education where it can be effectively used. When the new technology comes, there is always this, digital divide that happens in terms of you need to get experience about the technology, but you need expensive technology environment to make it available for them. Whereas if you have the AR or VR, it will be able to give you the immersive experience, hands-on experience, and you will be able to internalize the knowledge around how to make it work for you. Here again, the DDD, dull, dangerous and duplicate jobs are good targets for AR application. Let's say you want to train somebody for a disaster recovery, work in a nuclear plant, make them ready for operational sensibilities on what to do next and things like that. It is not a difficult thing anymore. It used to be a complicated thing. It's not a difficult thing anymore. So these kind of benefits is overwhelmingly helping everybody everywhere, right? So if you want to adapt this, what do I need to do is what is kind of indicated here. Devise an integration strategy for immersive experience, which will integrate the core experience, the incumbent application, which is, it could be a PLM, QMS, MES. There are several applications that are there. It's going to help identify feedback loops between the operator and the interaction between those applications. So a lot more need to be gained out of the immersive experience. In all the technology that we talked so far is all transformational benefits that you will have, right? So immediate gratification you will have if you are able to adapt the immersive technology. That's what I would say. And you could, like I said, what I have done is only taken 6 technologies as example. And there are over, if you look at the, let's look into the manufacturing part, right? There are several technologies that you will see here, right? So there are over 68 technologies that are there. And, even if you were to go back to indication of how many technologies are in the transformational realm, there are over 15 to 16 technologies that are there. At minimum, I would say, you need to be evaluating this. So that could be a good journey map you could be having. Let's look at the last part, right, which is the smart factory. We looked at smart assets. We are looking at smart factory. What are the difference between them? We already know that the smart asset is very close to distributed ledger or a blockchain technology tightly integrated with the business flow into that, right? Now, if you look at the smart factory, it's more like a concept that is used to describe application of different combination of modern technology to create hyper-flexible, self-adapting manufacturing capability. Sometimes you could call it as the industry 4.0, but it is becoming more than that. There is one other lecture that I'm going to be giving that's on the agile manufacturing. That again is kind of will lean on the smart factory, because sometimes your production could be disrupted. Your production capacity will have to be reconfigured and remodified for a new set of product. Modular design may be needed. So those are some of the requirements around the smart factory establishment, if you right. So in order to make it happen, we have to do a smart factory concept role as a part of agile supply system and integrated with the connected customer demand, because when the customer demand varies, your production will have to change as well. We'll see more in the agile manufacturing in a short while. And then we have to differentiate between the brownfield and the new greenfield capabilities, and we have to look at innovation as a way to make the smart factory happen. And identify the ideal technology combination that align with smart factory with specific segments and its supports, right. So as a concept, the underlying fabric will be the digital transformation integrated with the IoT that is collecting the data, and the edge analytics that is processing the data, and it's all combined into the AI fabric to help your overall manufacturing and production capability in a much more effective and efficient fashion. So these are the 6 important important transformational technology that we looked at. We looked at each of the categories actually, wait and watch. We also looked at the adapt, and we also looked at the pilot ones. So with this, I am just wrapping up the session. So to summarize, we looked at radar as a tool. We looked at emerging technologies. We looked at manufacturing technology, and each of the radar and the companions that we have. And then we went a little bit deeper, and we looked at transformation in technology alone. Took 2 samples of each of wait, pilot, and adapt, and we had a very good understanding, I hope. And when you look at this as a whole journey, this exercise could be something like a 2-day workshop to figure out what are the technologies that is going to make you more productive, more efficient, and then be adaptive in the future environment or in disaster environment as well. Thank you for the opportunity. Thank you.